Deep dive, understanding the problem in rate limiting. Designing a rate limiter starts with deeply understanding the problem you're solving. Let's break it down step by step to clarify why rate limiting is essential and how to define your specific requirements. 1. Why do you need rate limiting? Rate limiting serves multiple purposes. Prevent resource overload. Control the number of API requests to ensure your servers aren't overwhelmed by legitimate traffic or malicious activity. Ensure fair usage. Limit requests per user or IP so that no single entity hogs resources at the expense of others. Enhance security. Defend against bots, DDoS attacks, and brute force costs. Avoid excessive resource usage that can inflate cloud costs unnecessarily. Define rate limiting goals. To design an effective rate limiter, you must clarify, who are you limiting? Per user? Per IP? Per API key? How do you want to limit requests? Example, 100 requests per minute per user. What happens when the limit is exceeded? Block requests? Respond with an error? Log the activity? Notify the user? 3. Global versus per entity limits. Global rate limiting applies to all users or IPs combined. Example, your system allows a total of 10,000 requests per minute, regardless of individual users. Per user IP rate limiting. Each user or IP has its own request limit. Example, a user can make 100 requests per minute, independent of others. 4. Temporal requirements. Short-term limits. Example, 10 requests per second to prevent instant overload. Long-term limits. Example, 10,000 requests per day to control sustained usage. By defining these, you can combine limits at different time intervals to strike a balance. 5. Consider API characteristics. Not all APIs have the same requirements. Public APIs often need stricter limits to manage diverse, untrusted traffic. Internal APIs might allow higher or different limits since they serve trusted systems. Premium versus free users offer higher limits to premium users as part of tiered plans. 6. Handling exceeding limits. Define the behavior for when the rate limit is crossed. Soft limit. Send a warning or add a delay without fully blocking the user. Hard limit. Reject further requests with an error message, e.g. HTTP 429 too many requests. Logging and notifications. Log the events for future analysis or alert the user of excessive usage. 7. Edge cases to address DDoS and bot traffic. Quickly identify and block malicious IPs or unusual request patterns. Trusted users. Allow higher thresholds or exceptions for specific users or applications. Concurrent requests. Decide how to handle simultaneous requests that might exceed the limit. 8. Example problem statement. For example, if you're running a public API for an e-commerce platform, each user can make up to 100 requests per minute. Global traffic must not exceed 10,000 requests per minute. If a user exceeds their limit, they receive an HTTP 429 error with a retry after header. This clarity helps in defining algorithms, data structures, and workflows later in the design. Conclusion. Understanding the problem is the foundation of designing a rate limiter. By defining your goals, constraints, and edge cases, you create a clear blueprint that guides the implementation and ensures your rate limiter effectively meets your system's needs.